Hello everyone, my name is Mary and I'm a physics fanatic. My goal today was to capture an object moving at a constant velocity to depict the principles of Newton's second law. You may be wondering what exactly Newton's second law is. Newton's second law may be written as force equals mass times acceleration. And with this equation, we can predict trajected velocities and positions. If you know an initial velocity, and the net force, the summation of all the forces acting on an object, and the mass of the object, and the time duration of the activity that you're observing, then you can calculate a new velocity or a new position. Now, back to my original goal. If my goal was to capture an object at constant velocity, what would the net force be on my object? The net force would be 0. To display an object at constant velocity, I recorded a pepper container sliding across the table. I then uploaded 10 of the frames from the recording into Tracker to track the displacement of the pepper container for each of the 0.04 second frames. Using the first 2 points of displacement, I calculated the initial velocity. With the initial velocity and the initial position, which was 0, 0, 0, because I started the origin at the center of the object, I could create a computer model. The computer model used iterative calculations to model the trajectory displacement of the pepper container. When comparing the experimental and model positions, we see an inconsistency. The model data predicted a further final position. This is because the model assumed that the pepper container traveled at a constant velocity, which would be true if the net forces actually did equal 0. However, when we see a difference in my experiment between the initial velocity and the final velocity, we see that the net forces did not equal 0. Through some calculations, I was able to find that the actual net force was negative 0.184 newtons. I was able to derive this number through my initial velocity of 1.25 meters per second and my final velocity of 0.6 meters per second. Now, what could have explained this difference in net force? One explanation could be the sliding friction between the pepper container and the table, and another explanation could be that the pepper container was not actually traveling in a straight line across the table and was actually moving at an angle farther away from the camera. If I were to repeat this experiment, some things that I could do in the future to improve would be to either change my object or to change the surface that my object is moving on. If I were to use a more cylindrical or round object, say an orange or a ball, then I would only be facing rolling friction versus sliding friction. So my coefficient of friction would be much smaller. If I were to change the surface, then again, my coefficient of friction would be much smaller, and that would minimize my negative net forces. I hope all of you enjoyed my video, and have a great day!